Alright, last example. So, in this example, it says that... kenapa saya buka ni? Buka ni. Next. Example number 4. Alright. So, it says that, in this question, it says that a 25 milliliter of 0.50 acetic acid solution is titrated with... Maksudnya, acetic acid is your analyte. Your weak acid is your analyte. And with 0.50 molar of sodium hydroxide solution. So calculate the initial pH of the acid solution, okay, and then qualitatively predict the pH of the solution after the addition of 25 mils of sodium hydroxide solution. Okay, explain your answer. Then they gave you the acid dissociation, okay, for acetic acid dissociation constant. Okay, so right here, what is different from before is that now you have your weak acid, okay, your weak acid as your analyte. Okay, and your sodium hydroxide, your base, your strong base as your titrant. Okay, tak adalah surprise sangat yang tu. Tapi yang ni, your weak acid is as analyte. So, what we need to do is, sekarang we want to find the initial pH of the acid solution. Right? So, since your acid is a weak acid, your acid will not dissociate completely. Okay? If you look here, okay, when your weak acid, acetic acid, dissociate in water, it will form its conjugate base and hydronium ion. So this conjugate base is in your salt. Okay, from this salt here, your salt, right? So the Ka of your weak acid is given. So therefore, you can do the ICF table macam biasa. So sekarang ni dia dah bagi tahu molarity kan. So I'll just guna molarity yang ada tu. So you have 0.50 of molar of acetic acid. 0 ni dash. So your salt is not formed yet. So no hydronium ion yet. Okay. So the change in your molarity, you don't know. Okay, you don't know apa benda ni. You don't know the value of your dissociation for your weak acid. So you will put minus X. Okay. Ini will be plus X and then plus X. So maksudnya since dia bagi Ka kan, then awak boleh cari awak punya X tu. Okay. So since Ka is given, so you from your chemical equation, you can find the expression for the Ka of your weak acid. Okay. So masukkan the values, okay, from this table. So you can see that, ingat tak, awak punya Ka ni small, so that means you can assume that X is very small. X is very small. So therefore 0.5 minus X is just approximately 0.5. So here you can find Xk. Your X will be the concentration of your hydronium ion. It will be 3.0 times 10 minus 3 molar. Okay. So since we have the concentration of your hydronium ion, okay, sama je lah H plus tu, then you can find your pH. then you will get 2.52. Okay, so the initial pH of your acid solution will be 2.52. Okay, so then the next question is, it told you to predict the pH of the solution after you add 25 ml of sodium hydroxide. Maksudnya awak dah add awak punya base. So agak-agak what will happen? Okay, perasan tak yang awak punya awak punya solution ni is a buffer solution. Perasan tak? Okay, dah perasan dah? Okay, so sebab awak ada weak acid kan, dengan awak ada salt juga, awak form salt here. Okay, so that means you have a you have a basic buffer solution. Okay, so therefore what you have to ask yourself is that, what is the pH at equivalence point after addition of 25 ml of sodium hydroxide? So you need to perasan yang lagi satu, this part 25 ml of sodium hydroxide ni kan, since the molarity of your weak acid dengan sodium hydroxide, your strong base is the same. That means that the volume when 25 ml of acetic acid, 25 ml of acetic acid will be neutralized completely by 25 ml of NaOH. Okay, so itu actually your equivalence point lah. So at equivalence point for your buffer solution ni, your basic buffer solution, you will get a basic. So for this type of titration, weak acid dengan strong base, you will get a basic salt solution. Betul tak? So kalau macam tu, then your pH at equivalence point will be greater than 7. Okay, so the pH at equivalence points is more than 7, greater than 7. Why? Because the salt formed, salt is formed from neutralization of CH3COH, your weak acid, and sodium hydroxide is apa salt awak? CH3COONe kan. So when CH3COONe, your salt, okay, awak tunjuk dia punya dia punya ionization, you will form Ne+. Ingat tak? Allah, ini kena letak aqueous dengan your conjugate base. Okay, so between these two ions, only your conjugate base will dissociate, will react with water. Okay, so Teresa dia punya the hydrolysis of the salt pula. Okay, you will get, okay, so you will form OH minus equals, you will form hydroxide ion. So tak mahu dah saya nak tulis, so saya cakap je. So the CH3COO minus ni is a CH3COO minus is a conjugate base from your weak acid CH3COH kan. It is a conjugate base from a weak acid, so it can hydrolyze in water, okay, to produce OH minus ions, hydroxide ions. Therefore, this presence of hydroxide ion will show the basic properties of your salt. Therefore, the salt form is basic. Okay, the salt is basic. Alright, itu je. Okay, itulah yang awak nak explain kenapa awak punya pH tu greater than 7. Maksudnya awak tengah cakap pasal awak punya basic, basic lah. Awak punya formation of basic salt lah from this buffer solution. Okay. Alright, that's all guys. Bye-bye. Thank you. Oh wait. Bye-bye. So, last. Oh, itu je lah. So, habis lah 7.2. So, try to do the tutorial questions. Okay. Yang dalam awak punya buku tutor KML tu. Yang tu awak kena buat ikut step lah untuk nak draw titration curve, sketch titration curve. Awak kena buat initial, equivalence point, okay, and then pH jump, and then the final pH. Okay, alright, that's all. Bye bye.